I want to make sure the expectations on when I ask you to draw a scatter plot. It would be like this, where I give you the axes and everything that you need, okay? But I did not label the axes because I expect you to know that the length goes on the x-axis and the width goes on the y-axis. Okay, I'll give you the scale to help you guys with that component, but the length and the width and like the idea that you need to label your axes would be kind of an important idea that you need to show me that you know. Okay, from there, we're plotting a point. So like, so that first point is going to be 8.8 on the x-axis and 1.4 on the y-axis. This does not need to be perfect, but it needs to be close. So like 8.8 would be roughly here. 1.4, well, there's 1, would be roughly here. So I might expect that point. Does it need to be perfect? Absolutely not. But does it need to be close? Yes. All right, for any calculations, we're going to need to type the data in. So in general, you want to put your x variable in your L1. So in this case, that would be the length. Y variable in your L2. Everybody got it in? Okay. Now, to calculate R, there's two different ways we could go about calculating R. The one I'm going to show you is actually just running the test, because as you go through here, like if you guys go over to the next page, as we look at the very, very beginning of this, the question is just asking how are they related. It's not asking for positive or negative, so we're going to assume a two-sided test with not equal to as our alternative hypothesis, because it's not asking for evidence of a positive or evidence of a negative relationship between the two, okay? And so if we just go down and hit calculate, and what I would recommend we do here is kind of go through and fill in all the different things I'm going to ask you to do from these calculations. So, for example, the first question that we're going to use this is R equals 0.9799. We'll come back. All right, so calculate the sample's correlation coefficient and explain what it means. You guys, this is a 6-point question. Are you with me? This answer is very much not the bulk of the points of this question. The bulk of this question is, all right, just because we know what R is, that doesn't tell us what it means, okay? The explain what it means is the bulk of the points of the question, okay? So here's what I would expect you to say there. The relationship between length and width. Of perch is very strong and positive. I would be looking for context, strength, direction. Because that's what that means. If this was, instead of being 0.97, what if it was 0.6? I would call it moderately strong and positive. If it was negative 0.2, I would call it very weak and negative. Everybody good? Okay. All right. Our hypotheses are going to be about rho. It's always going to be somehow rho compared to 0. 0 being no correlation. R not 0 being a correlation. Okay, if I ask you, is it a positive correlation? Your alternative would be rho is greater than 0. Because positive would suggest bigger than 0, yes? Okay. All right, sketch the rejection region. Now, same set here, same set of expectations. Is this Z or T? T. What are our degrees of freedom? Ten. You can either do n minus 2, two variables, right? Length and width is two separate variables, or when you run the test, your calculator will give it to you, okay, to help you think through that. One-sided or two-sided? Two-sided. So what does that make the area of each tail? Do I not give you one? Let's use alpha equals 10%. That would make each tail 0.05, yeah? How do I find it? Inverse T. You guys, what was our Z statistic? Or T statistic? It was 15.54, which is like here. Actually, probably even further out. Most importantly, what can we say about that 15.54? It is in that rejection region. You're going to have to find a test statistic and p-value later on anyway. So we might as well go ahead, run that test, get all of our calculations, then we'll come back and make some sense out of them. Okay, so go ahead and hit stat test, and you're going to choose that linear regression t-test. Your X list is L1, your Y list should be L2. And we'll come back to this, but like over here, I ask you to provide the part G, I'm asking you to find the equation of the regression line. That's the A and the B. We've got R squared equals 0.960. We have our T statistic is 15.55 with a p-value of 2.476 times 10 to the negative 8. These are all different calculations that you get from doing the test in the first place. These are okay. Now, we can find these using the linear regression, but the test finds all of them for us anyway. Okay? Is everybody good so far? Now, as you guys are doing this, like this will all just be up on your, like you can run this again on your calculator if you forget to like look forward through the test. We have it all there. Okay. Everybody good? All right, so let's. Where my p-value is less than 0.10. If you wrote that there, it'd be fine. Okay, so we are going to reject. And if I reject, we're going to say at 10% significance, we can say there is a correlation between width and length of perch. Again, making sure we're not just making the conclusion, but doing so in context. Is feeling okay? All right, some other things I might ask you to do. If I give you the equation of a line, right? We already found the equation of the line to find the, to make a prediction. In this case, 20 centimeters long. Remember that X is my length, right? So that's telling me that's telling me X is equal to 29 and we're trying to figure out Y. So what we would do is take that exact equation that we just found and put 29 in for it. Okay, interpreting the R squared. I'll be very picky about this. 96% of the variability, so you're going to rewrite R squared as a percentage, just moving that decimal point over 2. Of the variability in widths of the purge. In other words, your Y variable can be explained by the relationship with the lengths. So, again, here's what I would be looking for. The 96% of the variability, the Y variable in context, explained by the relationship with the X variable. I'd be looking for each of those components. Okay? Any questions on the linear correlation questions? All right. Okay, for tests of independence, the null hypothesis is always that they are independent. The alternative hypothesis is always that the variables are dependent. Okay, so in this case, I might say response, again, test the claim that the response to the question is dependent on who asked the question. Okay, so my null is going to be response to the question is independent from who asked. Do you guys remember how to put these in your calculator? What do? You got to bring up the matrix menu. So second, whatever that, the x to the inverse. And then you got to arrow over to edit. And you can turn it into whatever size table you want. In this case, we have 2 rows by 2 columns. And put in your raw data. Okay, from here, to get the test statistic and p-value, you're going to hit stat arrow over to test. This time you're going to pick that chi-square test, letter C. Everybody good? Are you with me that my p-value is practically 0? Yeah. Which no matter what our alpha is, I'm gonna use 1%, but like on the test I'll double check, but I'm pretty sure I do a better job of giving you guys what alpha is. Then you would say, as your final at 1% significance. We can say the students' responses to the questions. Is dependent on who asked the question. Do we have questions? Do you guys feel like you have a good understanding of what I'm going to be asking you to do on tomorrow's test? Okay. Unit 11 homework still needs to be done. Unit 11 lab needs to be finished for a lot of you guys. Is there anything else you need from me? Any questions you have?